This video here is going to take you through examples 1, 2, and 3. Example 1 is going to be just finding the slope of the line. Okay. Examples 2 is a little bit of an application problem, so we're talking rate of change. And then example 3, we're going to determine whether the two lines are parallel, perpendicular, or neither. Okay, so example 1, I just want to find the slope. Okay, so you just watched a short video about finding slope of a line. And so first of all, the formula for the slope of the line, lowercase m, is equal to the change in y over the change in x. Okay, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so what we need is from any line, in order to find the slope, you need two ordered pairs, any two ordered pairs. We've got one here, 3, 3. Okay, I've got another one here, -2, -6. Okay, so with the 3, 3, what I'm going to do, okay, and this is just by chance that I picked this one over the -2, -6. Okay, I could start with that one. All right, what I want to do is I want to label these as x sub 1, y sub 1, or x sub 2, y sub 2. I'll call this point 1. So that's going to be x sub 1. Okay, and this is going to be y sub 1. So that means the -2, -6. Okay, now you're talking point 2. So this is x sub 2, and this is y sub 2. So when we throw this into our formula, slope is equal to, okay, and now I'm going to plug in things accordingly. It's going to be -6 minus 3 all over -2 minus 3. Okay, all right, so when we plug all this in, this is going to give me -9, and this is going to give me -5. Now, this is actually a really good example of a common error that's made. All right, look at my final fraction there. Okay, this right here. Now, that turned into me, I would mark it wrong. Think about it. Why would I mark that wrong? No, it's not that it's not reduced all the way. It's reduced all the way. But anytime, it's the negative signs here. This drives me crazy. Those negative signs, a negative divided by a negative, because that's what's really going on here. -9 divided by -5. A negative divided by a negative is a positive value. So you have to change anything that happens to pop up like that, where you have a negative in the numerator and a negative value in the denominator. You've got to make it positive. And you've got to tell me then your final answer here is 9/5, positive 9/5, which only makes sense, right? You've got a positive sloping line. Okay, we just drew that earlier in the notes. Okay, go ahead and turn the page. Okay, part B here. Okay, again, I want to find the slope. I'm going to not take quite as much time with this one and not quite as much detail, but you want to use your formula. Okay, and again, I come over here. All right, I'll pick this as point 1. Okay, and I'll say this is point 2. Okay, so when I start to fill things in here, slope is equal to, okay, y sub 2 is 2. Y sub 1 is 6, so I've got 2 minus 6. X sub 2 is 4. X sub 1 is -1. Okay, so 2 minus 6 over 4 minus -1. Okay, now 2 minus 6, we're going to get -4. Okay, down here, I always think less is better in situations like this. So remember, minus a negative is really a plus. Okay, so this is -4 over 5. Okay, and now this time, I just have a single negative sign. It's in the numerator. And even if it was just in the denominator, it wouldn't matter. My slope's negative. Okay, and I should know that it's going to come out to be negative by looking at that picture. Okay, because negative sloping line. Okay, if we put our little dude here, moving left to right, he's going downhill. Negative slope. Part C. Okay, horizontal line. Automatic. Slope is equal to 0. Vertical line, automatic, slope is equal to undefined. Okay. Example 2. Okay, have an application problem here. So rather than really, in all honesty, calling this slope, we would be referring to this as a rate of change problem. okay, in all likelihood. Okay. All right, so an example 2. All right, I've got two quantities here. I've got time in years, and then I've got dollars in millions. Okay, so we're trying to find, well, I should start here. We have a rate, okay? Our rate of change is $67.5 million per year. Okay, this is your rate of change, or in other words, this is your slope. Okay? From the other information, we're going to generate two ordered pairs. Now, I know we don't have a line. We don't have a straight line here. So it's we're not accustomed to creating ordered pairs just out of information. Okay, but that's what you need to do in this situation. Here's your two ordered pairs. Okay? The year 2000, okay, it says in 2000, the total sales were $1,003.2 million. Okay, so there's the information for one ordered pair. Okay, the other information, okay, comes from the question that's asked of you. What will the total sales be in 2005? That's your other ordered pair. Now, we don't know what the total sales would be, so this is going to be a variable. It's going to be X. Okay, now, how does this all fit together? Okay, well, what you see highlighted in yellow, that ordered pair, okay, is going to be 2000 and then 1003.2. Okay, now as far as what's the X and Y, okay, as far as what's the X and Y, that comes from this unit right here. Okay, so let's check and let's see if I did it right. Okay, $67.5 million, okay, per year. So we're talking millions of dollars per year. Okay, so if I'm looking at the slope formula, okay, reminder, slope formula, change in Y over change in X. So what does that tell me? That tells me that dollars has to be in the numerator, okay? Which means dollars then has to be my Y value, okay? Is dollars my Y value here? Yes, $1,003.2. And then the years in the denominator, that's where my X's are. Are my years my X coordinate? Yes. Okay, so that's how I have to determine which quantity comes first and which comes second. Now my other ordered pair, okay? My other ordered pair, 2005 is my X coordinate. And then let's change total sales. Let's just change it. Let's make it something different than X and Y so we don't get confused here. Okay, I like the letter J, so I'm going to call it J. Okay, total sales we'll call J. Okay, all right. So there's our two ordered pairs. Okay, so now we need to write an equation to figure this out. Okay, so to write this equation, we're going to use the slope formula. Slope is equal to, okay, all right, first of all, M, what's our slope? That's our rate of change. I labeled it in the problem, 67.5. Okay, y sub 2 minus y sub 1. When you're doing problems like this, the most recent ordered pair is your 0.2. So what's more recent, 2005 or the year 2000? 2005. So this is 0.2 and this is 0.1. The most recent data is your 0.2. Okay? All right, so x sub 2, all right, let me go back. Y sub 2, which is J, minus y sub 1, which is 1003.2. Okay? And then x sub 2 is 2005 minus x sub 1, which is 2000. Okay, so again, your most recent point, your most recent data is 0.2. Okay, so we go through all this. Okay, go through the algebra here a little bit. Okay, 67.5 is equal to J minus 1003.2 over 5. We're going to multiply each side by 5. What that does is cancels those two out. 5 times 67.5 is 337.5. Okay. Then I'm going to add 1003.2 to each side, and I end up with 1340.7 is equal to J. Okay. So what does that tell me? That tells me in 2005, my total sales were $1,340.7 million, because we're talking millions. Okay, a lot of stuff there. Okay, a lot of stuff in that problem. Okay, first of all, how to generate your ordered pairs. Okay, then what was our slope? What did we use for our slope? Well, we used the rate of change. Okay, and then how do I determine my x and my y coordinate? I use my units from the slope. And then how to determine what's point 1 and what's point 2. Your most recent point, your most recent data is always point 2. Okay, and that's example 2. Okay, moving to example 3. Okay, we're going to do a little graphing here. Okay, now there's some words missing here. Okay, what we want to determine whether xy, okay, line xy, and line WZ, we want to figure out if they're parallel, perpendicular, or neither. Okay, so here's the trick. Okay, if they're parallel, they will have the same slope. If they're perpendicular, and I'm going to use the symbol, okay, I'm being lazy, sorry. If I'm going to use the symbol, they have slopes that are opposite reciprocals, or their product is equal to -1. And then neither, okay, neither just means that the lines are going to, they're going to intersect somehow, except they're not going to intersect at a 90-degree angle because that would be perpendicular. Okay, so neither, how do we know if they're neither? Well, we know if they're neither if neither of these happens. Okay, so we've got to figure out the slopes of each of these lines. Okay, so first of all, the slope of line XY. Okay, you've got the ordered pairs up over there. We're simply going to use the slope formula. So I'm going to go 6 minus 5 over -1 minus 9. Okay, I'm going to get 1 over -10. Okay. All right, then I'm going to find the slope of WZ. Okay, and then the slope of WZ, I'm going to take 4 minus 2 over 12 minus -8. Okay, that's going to get me to 2 over 20, which reduces to 1 over 10. So what do I need to examine? I need to examine this guy, and I need to examine this guy. My first question is, are they equal? Okay, are they equal? Yes or no? No. One of them's -1/10 and one of them's +1/10. They're not equal, so they don't have the same slope, so they're not parallel. Are they opposite reciprocals? No. And then if you want to double check, well, if you multiply the two products, does it equal, or multiply the two slopes, does your product equal -1? Well, let's check it out. 1 over -10 times 1 over 10 equals 1 over -100. That's not -1. So guess what? They're not perpendicular. So guess what they are? They're what we call neither. Okay? Now, it does say, go ahead and graph these to prove it. All right. I'm going to come over to my graph. Okay, there's no XY axis on this, so I'm just going to create one. I'm going to use different color though. Actually, I'm going to do this just so I get some straight lines. When you guys graph, okay, especially on your homework, make sure that you have a straight edge, please. Okay. Okay, there we go. All right, so now when I graph here, right, XY first, 9, 5. Now I'm going to end up off the graph, but that's life. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then up 5. 1, 2, 3, 4, 5. So there's point X. Y is at -1, 6. There's Y. Okay, so I'm going to connect those dots here. Okay, connect those dots. Best I can. There we go. Straight line. Okay, use a straight edge. Okay, use a straight edge. Okay, and then WZ. W is at -8, 2. There's 8, I think. 1, 2, 3, 4, 5, 6, 7, 8. -8 and up 2. Okay, so there's W. And then Z is at 12, 4. Okay. 5, 6, 7, 8, 9, 10, 11, 12, 4. Okay, there is Z. Okay, so again, I'm going to connect those with a straight edge. Okay, all right, the best I can. And as you can see, they're not parallel and they're not perpendicular. Okay, they're going to eventually intersect over there to the right off the screen. Now, last but not least, we do have this example 4, but you're going to see that, okay, in another video.